Okay, I stumbled a few times here just by looking at the wrong thing and so forth, but you should be able very easily to calculate the slopes of all these vectors, the slopes of all the lines between these points. Now, when you calculate the slope, you've got to calculate it relative to the axis along which things change. So we calculated the slope here relative to the y-axis. And we do our picture relative to the y-axis. If we want to do the slope of the, let's see, the dA side, I'm going to draw that very quickly. You have, in the orientation we see here, we have vector 4k, that's the AP vector, that's AP vector. And we have the ds vector, which is 5k. We have the dA vector, which is negative I. And then we have the PS vector, the SP vector, sorry. Now the question is, what slope do we have here? Well, it's pretty obvious that this has a length of 1, and this has a length of 5, this has a length of 4. So the rise would be, if this is right, well, it's between 4 and 5, so the rise is kind of 1, but not really. Okay? If we want to see this, remember that if this vector is in the negative I direction, that tells us that the x direction would be this way. Now we can actually calculate it this way. There's something you can do, but I'm not going to do it. It's confusing enough to get the orientation right. Okay. So if I want the x direction to be that way, I'm going to have to put this to the right of this. I'm going to have to put the AP vector, the 4k, to the right of the 5k vector. So it's going to be 5k, 4k, and now your dA vector, well, this would be the point D, this would be the point A, just like here. This was the point D, and this was the point A. So your dA vector now goes in this direction, and you see you're going to have a negative slope. You can also see that from here, this is higher than this, so this vector dA here that I haven't labeled on this picture because it would be too, you'd have too much clutter, but this vector is actually going downward. And you want to be sure you understand that and visualize it. And you want to be able to do all this with your basic shape, and that's of course what I'm going to ask you to do. Okay. So that is the idea that I thought I was going to do down here, where you have to be careful of your orientation. You've got to be careful that your x direction is the direction that you want it to be. Okay, so here's the x direction. Now of course down here we use the y direction, up here we use the x direction. Why is that? Well, it's because the vector, this face here that corresponds to this picture is I want to use the right word. It's the y coordinate that changes as you move from one point here to another. The y and z coordinates change, the x coordinate doesn't. On this face here, the x and z coordinates change in this picture, but the y coordinate doesn't. So the one that doesn't change is going to be the one that defines the axis, and you kind of need to sort that out. I could have said that a little better, but I'll kind of leave it to you to figure out what you need to do in terms of the concrete shape that you have to deal with. Okay, so just talking a little about reversing, well, talk a little bit about the orientation of these sides, and one of the goals here is to get you used to visualizing shapes in 3 dimensions and understanding how you can isolate one face of this thing or another face and calculate meaningful quantities. I'm not going to talk about the terminology now. Okay.